So today we are going to do an experiment called How Fast Can It Dissolve? Okay? And we're going to talk about some of the 7 steps of the scientific method and some of the 6 basic processes while we go along. First, we have some expectations for you all. I want you guys to work good together. Okay? I want you to cooperate, and I want you to all contribute. So each one of us is going to have a part. Okay? We're going to follow the directions, so you need to listen to me so that I can tell you how to do the things so that we do them right and we do them accurate and we do them safe. Okay? Because we've got some really, really important material that is for our experiment that's going to be hot and some of it's going to be cold. Okay? So we need to be careful with those things. And then you're going to help me clean up. Okay? All right. So our very first scientific method step is we're going to state our problem. So our problem today is that we're trying to solve, trying to figure out the answer to is, does the temperature of water have an effect on the amount it takes for sugar to dissolve in that water? Okay? Now, we're going to gather a little bit of information. Our second scientific method step is gathering information. So I want to know what you guys know about dissolving. What can you tell me about dissolving? Do you know what it means to dissolve?
It's like it gets and kind of crumbles and turns into water.
Okay, so what was it you told me a while ago about dissolving? What was that very first word that you told me? That it makes it what?
Disappear.
Yeah, disappear. So that's the word that you used, was disappear, and that's pretty good explanation for you to tell me is that it disappears. It doesn't really disappear, but it does kind of become part of the water. Whatever we put in there, if it dissolves, it kind of becomes part of that water. It's mixed in, and you can't tell one from the other, right? So hot chocolate. Have you guys used hot chocolate before?
Mm-hmm.
So you've helped make hot chocolate, so you get your water, and you get your chocolate, and you put that powder in the water, and what happens? What happens to that powder? You can answer, Cole. What happens to that water? That powder. When we put the powder in the hot chocolate, what happens?
It turns into water.
So it kind of becomes part of the water. It mixes together with the water, right? And we're going to use these in just a second, okay? So we kind of use, we stir it up. Sometimes we use hot water and we stir it up, and some people just do cold water and stir it up and then they heat it. So it becomes part of
the water.
You can't tell the difference, can you? Once you get done, can you tell which was the powder and which was the water? Can't really tell them apart, can you? They're mixed together. Okay, so we're going to develop a hypothesis, and a hypothesis is our third scientific step. Now, a hypothesis is what? Do you guys know? No? So hypothesis, we can say, is a prediction. And when we predict something, we're using one of our 6 basic processes. And so when we're predicting something, we're kind of making an educated guess about what's going to happen. So if it was thundering and lightning outside and there were really, really dark clouds, what could we predict? What could we make a hypothesis about? What could we say if we saw those things outside? Coleman, what could we say? If it was thundering and lightning and the clouds were really dark, what could we predict? What do you think? Do you think maybe it was going to rain?
Mm-hmm.
Think maybe we could predict that there was maybe going to be a storm?
Mm-hmm.
Yeah? So that's a prediction. So we're going to make a hypothesis about our water. So we're going to decide if we think that we're actually going to decide which of the containers that we think is going to make the sugar dissolve the fastest. Okay? And we're going to have a hot water, a cold water, and just a room temperature water. So it's not really hot or cold, it's kind of in between. Okay? Now, designing an experiment. Designing an experiment is a part of our 7 steps of the scientific method. So we have to come up with a way to test this. And what we've decided to do is that we're going to have some containers, and we're going to have some water.
Also, Millimeter means like it's warm.
Room temperature means it's warm. Yeah. So it's not hot, it's not cold, it's kind of in between, right? It's warm. Okay. So we're going to have our containers, and we're going to measure our water out. We've got thermometers that we're going to use to test our water temperature before we put the sugar in. We've got a tablespoon that we're going to use to measure our sugar. We've got a timer because we're going to set our timers. Yep, we've got measuring cups to do the water with. So before we start, let's talk just a little bit about variables. Do you guys have any idea what a variable is?
No.
Okay, so a variable is, it's kind of like what we're testing. So in this instance, we've got identifying variables and we've got controlling variables. And our identifying variable is going to be the item that we are changing from each container. So each container is going to have something different in it. They're all going to be water, but what's the difference, Ben?
They're different temperatures.
The different temperatures. So the different temperatures of water is going to be our identifying variable. Now, we have controlling variables, which means those are the things that we keep the same. Ben, what's something that we're going to keep the same in each container? Are we going to have the same amount of what in each container?
Water.
Have the same amount of water in each container, and we're going to have the same amount of what else in each container?
Sugar.
Sugar. Very good, Cole. We're going to have the same amount of sugar. Now, we are each going to, when I tell you, we are going to pour our water into our measuring cups. We're going to fill it up to 8 ounces. Not yet. We're going to fill it up to 8 ounces, which is 1 cup. Okay, so you see the 1 cup right there?
Mm-hmm.
Okay, so we're going to fill that. We're going to put our water in there.
I don't see it.
Then, I think it's over on the other side, Ben. We'll turn that around. There you go. So we are going to measure our water. So that's one of our 6 basic processes is measuring. We're going to measure our water. We're going to measure the temperature of that water using our thermometers. We're going to place 1 teaspoon of our sugar into our water. Or I said teaspoon and you corrected me. Thank you so much. Tablespoon. You are absolutely correct. We're going to use a tablespoon of our sugar and we're going to put it into the water. And so that's going to be a measuring. So that's part of that 6 basic processes. And guess what? We are going to observe what happens, and that's another one of our 6 basic processes, is observing. And as we're doing all that, we're going to be writing down or recording our data. And that is one of our 7 scientific methods, is to record our data. So we're going to have to measure the temperature and write it down. Then we're going to have to measure the time, and we're going to have to write it down when we're done. Then we're going to talk about it, and we're going to see if we can come up with a conclusion, okay? And that's going to be one of those scientific method steps also. And while we're talking to one another, what are we doing when we talk to each other? We communicating with one another?
Mm-hmm.
Yeah? So that's one of those 6 basic processes. Okay, so let's get started so we can hurry up and find out which is going to be the fastest at dissolving our sugar. So Ben, that water is really hot, so I want you to be very careful, and I want you to fill it up to that 8 ounces. And Coleman, you said you wanted to use the colder water.
No, I actually want to use, now I want to use the middle one.
Okay, you want to use the middle one. All right. So we're going to take the top off.
It's like a
Now
little...
don't fill it all the way up, Ben. We're just putting 1 cup of water in there because we have to make sure that all of our water is the same amount. Put it to 1 cup. You think that's good, Cole? Let's see here. Oh, I think we got just a little bit extra. We can
I already put
pour
my
that in
thermometer
there.
in.
Okay, Ben has put his thermometer in. Okay, because we need to measure the temperature of our waters. Coleman has put his temperature in. We'll give it just a few minutes. And Coleman,
Mine is already done.
That's fine. I'm gonna help you, Cole, read your thermometer. I have used the cold water for mine since we only have 2 of us. Ben, do you want to help Coleman see if he can? Oh, are you going to help me?
That's
All right, thank you, Cole. Cole's helping me put my thermometer in.
That's
Okay, so let's see what your
It's like
room
six-
temperature
about like
says.
79.
Right, okay, so you see where the little mark is right here? You see where the red stops? So this would be 70. So this would be 72, 74, 76, 78, and 80. So where is it at right here? What would that be?
80.
Right here, this second line right here.
76.
76, does that sound right? Yep, okay. So can you write that down for me right here? You have the room temperature water, Cole. Can you write 76 degrees Fahrenheit there for me? Now I had the colder water, and while we've been sitting here, it's cooled down just a little bit, but it is still colder than our room temperature, so that's good. I am going to put that it is about, I can look at my thermometer. I'm just joking. Let's see, you come over here and help me, Ben. You think you can tell which dip what it is? Huh? Come over here and tell me. I think that it might be, I'm confused, Ben. I don't know if it's 60 or if it's more like 68. Can you tell? Can you look and see if you can tell what you think it is? You look.
66.
66. I think you might be right. So I'm going to write down 66. So it's not as cold probably as I would like it, but it's still colder than our room temperature and definitely colder than our hot. So what did yours say, Ben? Just out of curiosity.
120.
120. Gosh, that is very, 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 very hot. So
Yeah, it was burning my fingers.
yeah, I'm going to help you with that because that's probably just a little bit too
Yeah, you got it too.
hot for you to be handling. So here we go. I'm going to pour yours in just like that. Okay, I'm going to set the measuring cup right up here. Coleman is pouring his in. Awesome job right there.
We're doing ours in order.
Okay.
Hot to milk to water.
Okay. All right. Now let's get our sugar. Uh-oh, where did our tablespoon go?
I have it.
Oh, okay. Get you some sugar and put in there, please.
And I'll do mine. I'll do mine. A little more. I'm still not getting enough.
Okay, there you go. Go ahead and put that in there. And he's going to start his timer. Start your timer. All right, Coleman, here is yours.
Do we have anything to like stir it up?
No, we're just going to let it sit there and see if we can get it to dissolve.
I can see
All
mine
right.
dissolving just a little bit.
You can see it as dissolving already just a little bit.
Yeah.
Okay, and mine's the cold. Coleman, do you see yours doing any kind of dissolving? You see your sugar moving around or doing anything? Mine's not doing much. Mine looks like it's sitting on the ground, but
Mine is almost gone.
and we have got these other timers started here. Oh, it looks like I can see fewer and fewer and fewer of Ben's, doesn't it, you, Cole? What do you think? Think it's going down a little bit further, a little bit further?
I have less than Coleman's and Mom and yours.
Mm-hmm.
And Coleman has less than yours. You have the most.
So while we're looking at these, observing, what can we already tell?
That the hot water is dissolving
The hot water's dissolving the quickest? Yeah.
Fastest.
The fastest, yeah. And so based on that, we could say that the hot water does dissolve sugar faster, right? Can you all think of something that would make a real life connection to this? Because if we apply it to ourselves and we can make a connection to something that we know, then that's one of our 7 scientific method steps. Can we connect it to anything? We'll go ahead, we can write down our times here in just a second. Ben, go ahead and stop your timer and you'll be able to write down your time. Do you remember what Corbin was talking about when we looked at doing this the other day? Do you remember what he used as an example of dissolving at the end that he said that he was reminded of? He said that this reminded him of what? Yeah, say it. Reminded him of what?
I don't know.
It had to do with the bath, right?
Yeah, I can't remember.
So Corbin said that this reminded him of when he would get into the bathtub and his mom would put like these little bath beads in there and they would dissolve as soon as they got in the bathtub because it was hot. And that was a great way to connect dissolving to something in his life. Something else that reminds me of is Kool-Aid. Don't put your finger in it, remember it's really hot. Kool-Aid is what it reminded me of because when we, please don't put your finger in it. Because when we use Kool-Aid and we use hot water to mix our sugar up, we get Kool-Aid really fast because we can stir it and that sugar dissolves, right?
Sugar on the table.
Yeah, there's sugar on the table. We have a cover, so it's going to be fine. All right. Great job. We're going to finish recording our data here, and then we may continue to have a little bit of a conversation, but that's our experiment. Can you guys say goodbye?
Bye.